Okay, so LT4 talks about proving and applying basic trig identities. So, first definition then is just a basic definition for an identity. So it's an equation that is true for all values of the variables for which the expressions are defined. So basically that one side of your equation equals the other side. And first we're going to have our reciprocal identities. And we know sine, cosine, and tangent. Those are our basic trig functions. And we know that sine is equal, if we think about our right triangle, and we're saying from this angle, well, sine then is our opposite over our hypotenuse. Cosine then is our adjacent over our hypotenuse. And then tangent is our opposite over our adjacent. And make sure you note that tangent is also equal to sine of A over cosine of A. And you can see that by taking your opposite over hypotenuse, dividing that by your adjacent over hypotenuse. So your hypotenuses cancel out and you're left with your opposite over your adjacent. So then, on this other side, they've kind of paired them up. Cosecant is the reciprocal of sine, or 1 over sine. So if we take 1 over the opposite over the hypotenuse, we actually then get the hypotenuse over the opposite. Same thing with secant. It's going to be our reciprocal of cosine. So we take 1 over cosine, so 1 over adjacent over hypotenuse, and we get then hypotenuse over adjacent. And then cotangent, reciprocal of tangent, so 1 over opposite over adjacent, or adjacent over opposite, or in terms of trig functions, this is actually going to be cosine of A over sine of A. So we've just taken the reciprocal of everything from our sine, cosine, and tangent. And what you're going to do is you're going to use these to prove identities. So if you have something that says cosecant, well, then you can plug in your 1 over sine, and it'll hopefully be able to help you like multiply or factor something out. So we'll try one of these examples. And it says, does cotangent of x equal cosine of x over sine of x? And what you're going to do is you're going to choose one side to work on. With the identities, you're only ever going to work on one side, and you're going to try and make that side equal to the other side. So if I take cotangent of x, if we look back at our reciprocal identities, and this example is under where it says Pythagorean theorem, or Pythagorean identities. So if we look back at the reciprocal identities, cotangent is equal to 1 over tangent. So we can plug that in. So we'll say 1 over tangent of x is equal to cosine of x over sine of x. And we'll kind of put our question mark above our equal sign because we're still trying to figure out if it's equal. So we said on the last page that tangent is equal to sine over cosine. So we'll keep that, and we'll write sine of x all over cosine of x. And again, we'll keep our question mark because we still haven't proved if it's true or not. All over sine x. So then we can kind of see then that when we divide 1 by sine of x over cosine x, the cosine x is going to flip up into the numerator. So then we have cosine of x all over sine of x is equal to cosine of x all over sine of x. And we can obviously see that our left side equals our right side, so that is true. And you might be asking, well, why did we prove that? We already knew that that was the reciprocal. Well, it was just a good way to see that using part of the reciprocal, so maybe one part of the definition, that cotangent is equal to 1 over tangent, we were able to kind of extend that into seeing that that is why our reciprocal exists. And you won't always be proving the identities themselves. You'll often be proving kind of they'll throw a bunch of trig functions and multiply them and add them, and then you'll have to prove if that equals the other side. So then we've got Pythagorean identities, and those are identities that come from right triangles, the Pythagorean theorem, and the unit circle. So on our unit circle, we had a radius of 1, and we could draw kind of our triangles. And we said that our x and our y, and in our packet, so from our unit circle investigation, we recognize that x squared plus y squared should equal our radius squared, which was 1. Well, and then if we think, our x coordinates gave us our sine our sine values, so we can plug in sine of a there, and we'll square that. So we'll put the squared just after the sine, just a matter of notation. Then our y values are our cosines, and actually, nope. Our x's are our cosines, and our sines are our y coordinates, which you have written on your other page. So from LT3, you can plug in your x coordinate and your y coordinate, so your cosine and your sine. So then we can see then that we've gotten this first identity just by plugging in what we know for our x coordinate and our y coordinate. So then we can try and prove this second one. So 1 plus tangent squared a equal to secant squared a. And I'm going to start on my left side. You could start on your right side, but it's just matter of preference. I like to start on the left. So we said earlier that tangent was equal to sine squared a all over cosine squared a, and I'm just making them squared because the tangent itself was squared. So we're going to keep that equal to secant squared a. If you want, you can draw in your question mark there because we're trying to prove it. So then I want to make this all one term on my left side. So I'm going to multiply my 1 by cosine squared a all over cosine squared a. So then, once I multiply those and add them together, since they now have the same denominator, I'll get cosine squared a plus sine squared a all over cosine squared a. I'm trying to see if that's equal to secant squared a. Well, we know from our first one that cosine squared a plus sine squared a is equal to 1, so we can plug that in. So then I get 1 all over cosine squared a, questionably equal to secant squared a. And if you look at your reciprocal identities, so if we flip back over here, 1 over cosine a is secant a, so 1 over cosine squared a is going to be secant squared a. So then we can see secant squared a is equal to secant squared a. So what I want you to do before class, try and prove this identity using your reciprocal and Pythagorean identities, and then also try these 2 before class problems. And like I said, start on one side and try and either get common terms or multiply or anything you can kind of do to make it equal the other side. And just remember kind of your rules of algebra. So there we go.